Hey, welcome to this video on the golden ratio. This is the final lesson in our first unit of Algebra 2 about quadratics. And the reason we're going over the golden ratio is because it does become derived with the quadratic formula. And so here we go. One way to derive the golden ratio is through what is called a golden rectangle. And a golden rectangle is a rectangle that can be divided into a square and a rectangle which is similar to or proportional to the original rectangle. We did talk about the golden ratio in geometry as well. So we're going to let the width of the rectangle, the short side I'm going to refer to as the width, and the long side I'm going to refer to as the length because it's longer and they both start with L. So we're going to let the width be 1 and then find out what do you multiply by the short side to get the length of the long side, x, that we don't know. Now, once we divide that into a square, which is going to be 1 by 1 by 1 by 1, this remaining rectangle will be proportional and scaled to the original big rectangle. So I have a picture here with the big rectangle broken into the square and the similar rectangle, and then the side, a rectangle that's just the pink one pulled out so that we can see the two similar rectangles next to each other. So this is going to be 1, and this whole side is going to be x. So since this side is 1, that means so is this one and so is this one, because opposite sides of a rectangle are equal. And since it's turned sideways here, that's going to be 1. All right, and then if this side is 1, this side is 1, so this is going to be x minus 1. X minus 1, which means this is x minus 1 because it's the short side of the smaller pink rectangle. So let's set up and solve a proportion that will give us the ratio of the long side to the short side in a golden rectangle. So I'm going to say x here to 1, long side to long side, is equal to short side to short side. So that's going to be 1 to x minus 1. This is an equation. I'm going to solve for x. I'm going to cross multiply. So x times x minus 1 equals 1. X squared, oops, that could be nicer. X squared minus x when I distribute equals 1. So x squared minus x minus 1 is equal to 0. So now this is a quadratic equation. And in that quadratic equation, a is 1, b is negative 1, and c is negative 1. It does not factor because there's nothing I can multiply to get negative 1 that adds up to negative 1. So I'm going to use the quadratic formula. Negative of b, which is negative 1, plus or minus b squared minus 4 times a times c over 2 times a. So 1 plus or minus negative 1 squared is 1. Negative 4 times 1 times negative 1 is positive 4. So it's 1 plus or minus square root of 5 over 2. Okay. So that means I have two solutions for x, 1 plus root 5 over 2 and 1 minus root 5 over 2. If I do 1 minus root 5 in my calculator, I get negative 1.23606 blah, 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 blah over 2, which is going to be a negative number. And since this is representing x, the side of a rectangle, we can't have a negative number for that. So this solution we are going to discard. If I do 1 plus square root of 5, I get 3.23606 blah, blah, blah over 2, which is approximately 1.618. So that means that x, because when you do the quadratic formula, you're getting the solutions for x, is approximately 1.618, So if you take the short side and multiply it by 1.618, you'll get the long side. If you take the long side and divide it by 1.618 in a golden rectangle, you will get the short side. Keep in mind, not all rectangles are golden rectangles. All right, so let's compare the ratio of the length to the width of a golden rectangle with the ratio of the width to the length. Well, the exact length to width is 1 plus root 5 over 2, which is approximately 1.618 to 1. Now, if I want to flip that upside down, the width to the length is 2 over 1 plus root 5. Now, in my calculator, I'm doing 2 divided by, and then in parentheses, 1 plus the square root of 5, which is basically 1 over 1.618. That's approximately 0.618, which I think is interesting that it has the same decimal places. It's just with a 0 in front instead of a 1. So the reciprocal of it has the same decimal values after the decimal. Okay. So let's draw a picture and solve. A golden rectangle has a length of 12. Okay. So the long side is 12. What is the exact value of its width, the shorter side? So we know that the length to the width is 1.618 to 1. So that's 12 to x, length to width. I can solve this as a proportion. I forgot to put the x after my 1.618 because it is multiplied by x. And that's going to equal 1 times 12, which is 12. So divide both sides by 1.618. 12 divided by 1.618 is approximately 7.42. I'm just going to the it said nearest tenth, so we'll just go 7.4. Okay, we don't have any units on this to worry about. Now, one of the things I forgot to mention that I do want to go back and say is this value 1.618 is called phi, which is a Greek letter like pi or whatever, and that's the symbol for phi. All right. The next one, we have a golden rectangle with a width, that's the shorter side of 8. What is the exact length? I'll call that x. Well, we know the length to the width is 1.618 to 1. All right, so that's x over 8. So because we have the shorter side, that is why our x is in the numerator. We're looking for the longer side, as here it was in the denominator. So 1x, or just x, is 8 times 1.618, which is 12.944. So we're going to go approximately 12.4. Now you can solve these for the exact value, which I had said that we haven't gotten to our units on radicals yet, so I'm not making you do it. But if you remember from Algebra 1, you can solve it that way and do length to width is 1 plus root 5 over 2 is 12 over x. So instead of using the decimal approximation, you can use the radical approximation and solve that exactly. So we could have 1 plus root 5 times x equals 24. We divide by 1 plus root 5 on both sides. So x is 24 over 1 plus root 5. And if you remember how to do the conjugate to reduce that radical and have no radical in the denominator, or rationalize, you can do 1 minus root 5 over 1 minus root 5 to simplify. So it's 24 minus 24 root 5. And 1 plus root 5 times 1 minus root 5, if you FOIL that out, you get 1 minus root 5 plus root 5 minus root 5 times root 5, which is 5. So 1 minus 5 is negative 4. Traditionally, we don't have a negative in the denominator. So what we will do is run the negative through the numerator, or in this case, I can just divide both these by negative 4 because it does reduce. 24 over negative 4 is negative 6, and then negative by negative is positive. So you could get that answer as well. All right, so this one I'm going to do the same thing to work it out. Length over width is 1 plus root 5 over 2, which is x over 8. So I'm using the exact value instead of the decimal value. I'm going to cross multiply. This one's going to be a little simpler. 2x equals 8 plus 8 root 5 when I distribute that. So I just divide both sides by 2, and I get 8 over 2 is 4. 8 over 2 is 4. So 4 plus 4 root 5. If you check your decimal values, this does equal approximately 12.9. It was 944, and I accidentally wrote a 4 instead of a 9 right there. All right, and I can do the same thing for the one above it. If I do negative 6 plus 6 root 5, okay, I can see that it equals about 7.4 on my calculator. All right, so that is the end of this lesson on golden rectangles. We will be reviewing soon for our summative, and the next lesson will be the beginning of Unit 2.